Good morning, ladies and gentlemen. My name is Christine Figener, and I'm speaking on behalf of the Leatherback and Pacific Green Sea Turtle Research and Conservation Project in Ostional Costa Rica. Today, we would like to share with you the results of a management strategy that helped us to raise the hatching success of our leatherback nests in Ostional. First, I will give a short introduction to the conservation issues we are facing in Ostional. Next, I will talk about the conservation focus of our first nesting seasons and the shift in focus from 2011 onwards. Then I will present our results, and in the end I will give a short conclusion. I'm sure many of you will be familiar with Ostional, but for those that are not, here a quick digression. We are located in Central America on the Pacific coast of Costa Rica, on the peninsula Nicoya in the province Guanacaste, and Ostional is a management unit consisting of Playa Ostional and Playa Nosada and includes roughly 7 kilometers of suitable sea turtle nesting beach. Most people know Ostional because of the synchronized mass nestings, in Spanish arribadas, of the olive ridley turtle. Few people, though, are aware that also two other sea turtle species use Ostional to nest as well. One of them is the still critically endangered eastern Pacific leatherback turtle, and the other one is the Pacific green turtle. Both species flew pretty much completely underneath the radar up until 2005, where the leatherback and Pacific green sea turtle projects started to monitor the beach in Ostional. But already during the first nesting season, it was pretty clear to us that Ostional was unlike any other nesting beach we had worked on before, with very unique issues, especially for our nesting leatherbacks. Most issues and resulting conservation challenges in Ostional are related to the incredible spectacle of the arribadas, which take place almost every month of the year. Quite impressive, but also quite detrimental. For instance, as the nest density in Ostional is incredibly high, on parts of the beach up to 5 nests per square meter. Furthermore, sand temperatures are often beyond the lethal threshold due to nesting taking place in the dry season, missing vegetation on the beach, generally rising temperatures, but especially due to the high nest density and huge amount of decaying olive ridley nests, which also give the sand an almost soil-like texture. Here you can see the sand temperatures of the 2010 and 2011 nesting season, meant as a control. On the y-axis, you can see the different temperatures in Celsius, and on the x-axis, you can see the month of our nesting season. And we have marked the pivotal temperature of leatherback nests as well as the lethal threshold for incubation. And you can see that most temperatures are actually beyond the lethal threshold. All this taken together, our leatherbacks faced a 0% hatching success in their natural nests. While making another short digression to show where most nestings happen in Ostional, we can see that Playa Ostional, where the arribadas take place, host about 88% of our leatherback nests, and Playa Nosada only about 12%. While looking though at the sand temperatures in Nosada, you can see that the temperatures marked here should allow incubation, but unfortunately we face a different kind of problem in Nosada. And that is aggressive poaching. So we've got poaching in Nosada and high sand temperatures in Ostional. And early on the decision was made to relocate leatherback nests into a protected and managed beach hatchery. So that is our hatchery from the air. And this hatchery was always constructed following the IUCN guidelines, and the sand was sifted to remove bigger organic matter and debris. That is again the hatchery from the front and from the inside. The focus of the first 6 nesting seasons was to lower the sand temperatures to a level that allows incubation in the hatchery. And for that, we tried different kinds of shading with 80% saran in different colors and different numbers of layers on the roof and the sides. Here you can see the inside with the shading, the construction of the shading, how the black shading was applied in one season, and how the green shading was applied in another season. And that are 4 examples of 4 different nesting seasons, what the hatchery looked like. The mean hatching success rose as a result of the shading, but unfortunately not as high as we hoped for and never beyond 30%. The analysis of our temperature data revealed that temperatures inside the hatchery were way below the lethal threshold. And the mean incubation temperature of the first 5 seasons with 30.9 degrees Celsius was also below lethal levels. Unlike the mean incubation temperature of leatherback nests in situ. Since sand temperatures inside the hatchery were now sufficiently low to allow incubation, the question now was what else might be the reason for the low hatching success. Maybe humidity levels, which proved to be quite difficult to manipulate during the dry season with only limited funds, or oxygen levels. So we moved the hatchery a few meters closer to the waterline to enhance tidal ventilation, but with no further effects. And the next idea that occurred was that maybe the microbe load might be the problem. Since most nests showed a high level of bacteria and fungi infestation during excavations, and given the quantity of decaying matter on the beach, the idea didn't seem to be far-fetched. Furthermore, sand temperatures are often beyond the lethal threshold due to nesting taking place in the dry season, missing vegetation on the beach, generally rising temperatures, but especially due to the high nest density and huge amount of decaying olive ridley nests, which also give the sand an almost soil-like texture. So here you can see us digging the pit for the hatchery, and our volunteers sifting the sand from the low tide zone and carrying it up to the hatchery. In the first trial, we filled only half of the hatchery with the new sand, and the other half was left as in previous years as control, and the sand there was only sifted. Incredibly, in the half with the new sand, the hatching success rose to 61.5%, whereas in the half with the old sand, the hatching success remained at 32.9%. The hatching success remained higher. In the 2012 and 2013 seasons, we had a mean hatching success of 52.5%. and in the past nesting season, a mean hatching success of 58.5%. Preliminary lab results from sand analyzed during the first round indicate a lower level of microbes in the new sand compared to the old sand and sand taken as a control from the beach directly. Due to the small sample size, we are unfortunately not able to give any statistics. A comparison of the grain size showed that the new sand features bigger grains, which might be the reason for the more sand-like texture previously mentioned. As a conclusion, we can say that the new management strategy works to raise the hatching success of our leatherback nests and will be continued. But to make a conclusive statement, though, of why the sand from the low tide zone raises the hatching success, more comprehensive studies are needed. Questions in need of answering concern the oxygen levels and the humidity levels, as well as other properties of the new sand. First, I will give a short introduction to the conservation issues we are facing in Austria now. Next, I will talk about the conservation focus of our first nesting seasons and the shift in focus from 2011 onwards. Then I will present our results, and in the end I will give a thank you very much.